Everything you know about construction is a lie. For decades, we've been building our world out of dead materials. Concrete that cracks, steel that rusts, bricks that stifle the planet. Did you know that the global construction industry is responsible for 40% of all CO2 emissions? Every skyscraper you see is essentially a massive carbon debt we can never repay. That's not progress. That's a planetary disaster. But imagine a skyline that doesn't just sit there like a graveyard of gray stone. Imagine a city that breathes. We are moving past the age of the crane and the bulldozer, because right now the most advanced engineering on Earth isn't happening in a high-tech lab. It's happening in the dirt beneath your feet. We are no longer just building cities. We are cultivating them. And the part that should terrify every traditional architect, we can grow a structural wall in just 5 to 7 days. Welcome to the fungal revolution. Concrete is a fossil. It's heavy, it's brittle, and it's slowly suffocating our atmosphere. We treat it like the gold standard of strength, but in reality, it's a ticking time bomb of maintenance and decay. Every spiderweb crack in a sidewalk and every crumbling bridge is a reminder. We are still building with primitive Stone Age logic. So, why are we stuck? Enter the ultimate scientific hero. And no, it's not a laboratory-made metal alloy or a fancy liquid plastic, it's mycelium. But forget the mushrooms you see on a pizza. We aren't talking about soft, squishy vegetables. Deep inside these fungal networks lies a hidden structural superpower, chitin. This is the exact same biological armor found in the rock-hard shells of crabs and the impenetrable exoskeletons of beetles. It's nature's high-tech molecular glue. When mycelium goes to work, it uses this chitin logic to bind agricultural waste, like hemp or sawdust, into solid blocks that are naturally fire-resistant and possess a higher strength-to-weight ratio than many traditional materials. Think about that. Nature has been perfecting structural engineering for 1 billion years while we've been playing with mud and fire. If biology already solved the puzzle of durability, why are we still wasting billions on bricks that break? The answer isn't just about raw strength, it's about intelligence. And this is where the story gets truly weird. Now, I know what you're thinking. If we build our houses out of fungus, won't they just rot? Or worse, could we be living inside a scene from The Last of Us? It's the ultimate zombie fear. The nightmare of breathing in toxic spores or living inside a damp, smelly mushroom. But the reality is the exact opposite. These aren't rotting heaps of compost. They are highly organized, hyper-clean biological systems. Look at the research from the University of British Columbia. They developed a myco-toilet that uses fungi to break down human waste. The results? It neutralized 90% of odors without a single drop of chemicals. If a fungus can turn a sewage system into a clean, odorless environment, imagine what it can do for your living room. And here's the kicker. These structures aren't alive in the way you fear. Projects like Fungar are proving that we can render these materials biologically inert. Through a precise heat treating process, the fungus is turned off. It doesn't release spores, and it doesn't grow uncontrollably over your furniture. In fact, these blocks are safer than the homes we live in right now. Mycelium is naturally fire retardant. While traditional wood framing turns into a tinderbox the moment a spark hits it, fungal bricks don't ignite. They char slowly, creating a carbonized heat shield that protects the structure's core. You aren't living in a decay trap, you're living in a biological vault. But if they are rendered inert, how do they stay smart? This is where the line between biology and technology completely disappears. Because these buildings don't just sit there, they think. This is the moment where the secret design finally comes to light. It's called the Fungar Project, and it's rewriting every rule of architecture we've ever known. We've always treated buildings like static, dumb objects, stacks of stone that just sit there and decay. But Fungar is creating something entirely different. Biological computers. These aren't just walls, they are laced with a grid of living fungal mycelium that acts like a primitive nervous system. Through a process called bioelectric signaling, these fungal networks can sense environmental pressure. They can feel the weight of heavy snow on the roof, detect toxic shifts in air quality, and even respond to light levels, all without a single copper wire or silicon chip. But here's the game changer. Remember those thousands of dollars in maintenance I warned you about? When a traditional concrete wall gets a micro crack, it's the beginning of a slow death. Water seeps in, the internal steel rebar rusts, and eventually the entire structure fails. But a fungal building doesn't just sit there and break, it heals. By keeping specific vascular pathways within the mycelium dormant but ready, these walls can sense a structural breach. The moment air or moisture hits a crack, it wakes up the fungi in that specific specific zone. The mycelium then grows fresh, dense fibers to seal the gap and reinforce the bond. It's exactly like your skin healing a paper cut. Repairs become a natural, autonomous biological function rather than a $1,000,000 construction project. We aren't just talking about a new material anymore. We're talking about a modular, self-sustaining organism that manages its own upkeep. But does this actually work in the real world, or is it just a fantasy in a lab? The proof is already standing. This isn't just a lab experiment, it's happening right now on the streets of Ohio. Look at the Cleveland Biocycler. This project is a total disruption of the status quo. They take the trash from abandoned, demolished houses, drywall, wood scraps, and debris that usually sits in a landfill for centuries, and they feed it to the fungi. The mushrooms literally digest the demolition waste, binding the carbon-rich trash into brand new, high-strength structural bricks. It's a closed-loop system where the ruins of the old city literally birthed the foundation of the new one. No mining, no furnace, no waste. But if you think that's big, look up. NASA is already pouring research into myco-architecture for the red planet. Why? Because shipping steel and concrete to Mars is a logistical nightmare. It's too heavy and costs tens of thousands of dollars per pound to launch. But a small, lightweight bag of fungal spores? That fits in a backpack. NASA's plan isn't to build habitats, it's to seed them. By adding water and basic nutrients to Martian regolith, they can grow radiation shielding structures that are tougher than concrete. Think about the logic. If this technology is robust enough to shield astronauts from the vacuum of space and cosmic radiation, it is more than enough to weatherproof our suburbs. But what does this mean for your bank account? Because this isn't just about saving the planet, it's about saving your future. This is where the biological revolution meets your bank account. In our current world, building a home is a financial nightmare. You are trapped in a supply chain of high-cost raw materials that have to be mined, melted in coal-fired furnaces, and shipped across the globe. But in a fungal city, the raw material is effectively free. Mycelium doesn't need expensive limestone or iron ore. It grows on waste, the husks, stalks, and sawdust that farmers currently pay to haul away. By turning this agricultural byproduct into structural gold, the cost of building materials could plummet towards zero. We aren't just talking about eco-friendly housing, we are talking about a total financial disruption of the real estate market. And it gets even better for the planet. Instead of being carbon positive, where every brick you lay adds another ton of CO2 to the climate crisis, these buildings are carbon negative. Because fungi consume carbon as they grow, they lock that carbon away inside their walls for centuries. Imagine a future where your house isn't a liability or a monthly expense. It's an asset that earns you green credits simply by existing. Your home would literally be cleaning the atmosphere while you sleep inside it. We are moving from the age of extraction, where we destroy the earth to build a shelter, to an age where our shelter is the very thing that saves the earth. But there's one last secret we haven't uncovered. The secret design I promised you at the start isn't just a new kind of brick. It's a fundamental shift in how humanity exists on this planet. We are finally moving away from the age of extraction, the era where we rip, mine, and blast materials out of the earth, and entering the age of cultivation. By partnering with the fungal kingdom, we aren't just building shelters. We are creating a living, breathing harmony with the most successful engineers in biological history. These systems don't just stand there like static monuments. They adapt, they heal, and they flow with the ecosystem around them. Imagine a world where your neighborhood isn't a dead concrete jungle, but a vibrant modular ecosystem that gets stronger every single day. This isn't science fiction. It's the logic of the future. It's efficient, it's beautiful, and for the first time, it's finally within our reach. But as crazy as living skyscrapers sound, this is only the surface of what this biological network can do. If fungi can use chitin to build our walls and use bioelectric logic to think like a computer, what happens when we shrink that technology down? If mushrooms can build our cities, can they also grow our electronics? What happens when your next smartphone is grown in a lab instead of being mined from a mountain? That is a story for next time.